Good morning, students. Welcome to the class. In today's class, we are going to discuss the properties of the incenter and how can we calculate the radius of a incircle. Okay. But before starting, I just wanted to tell you something important. From this video, we will start diving a little bit deep. Okay. I mean to say, in previous session, we just discussed that basic properties of the circumcenter and direct formulas of the circumradius. But now we will start discussing the proof also, that how the particular formula was derived. Okay, suppose I am discussing a formula with you, then I am going to tell you the proof of that particular formula. Understand that? So let's start. Now firstly we have to understand that what is a incenter. Okay, in previous sessions we have discussed about the centroid and the circumcenter. As we know, the intersection point of the medians is known as centroid. Okay, in the same way we discussed that intersection point of perpendicular bisectors of the sides is known as circumcenter, and there is one more definition for the explanation of the circumcenter, and that is that a point which is equidistant from each vertex is known as a circumcenter. Now we are gonna to discuss incenter. What is incenter? Okay, suppose there is a triangle. Okay, name of the triangle is ABC. Okay, this is a triangle and name of the triangle is ABC. So I would say that intersection point of each interior angle bisector, intersection point of each interior angle bisector will be known as incenter. So I'm dropping interior angle bisectors of each angle. Okay, so these are the interior angle bisectors. If these are the interior angle bisectors, then each angle will be divided into two equal parts. Okay, so this part and this part will be equal, and this part and this part will be equal, and this will also be equal, and this point will be known as incenter. Understand that? So you have to just keep this thing in your mind, that intersection point of each interior angle bisector is meeting at a particular point, and that intersection point will be known as incenter of the triangle. Now we will try to discuss that what are the uses of this incenter. Okay, as we discuss the circumcenter, if we are trying to draw a circle from the circumcenter, that circle is just passing through the each vertex of the triangle. In the same way, if we are going to draw a circle from incenter, this circle is just going to touch each side of the triangle internally. Okay, so if this is the center of this circle, then the circle will be like this. Okay, so this circle is just touching each side of the triangle. Okay, and this circle is known as the incircle. This circle is known as incircle because it is drawn from the incenter. So that's why we are gonna to call it incircle. Okay, and the radius of this incircle will be known as inradius, will be denoted by small r. Okay, so its radius will be known as radius of this circle. Radius of this circle will be known as inradius. Radius of this circle will be known as inradius. Okay, and will always be denoted by small r. Now we will try to discuss the properties of this. Okay, and there is one more definition of the incenter. As in the circumcenter we discuss a point which is equidistant from each vertex of the triangle, that is known as circumcenter. In the same way, what is incenter? Incenter is also a point which is equidistant from each side of the triangle. Suppose this is the triangle and this circle is the incircle. So you know what is radius. Radius means a distance from center of the circle up to circumference of the circle. So this is the center of the circle and this is the circumference. So this portion will be known as in radius r, and this is also in radius r, and this is also in radius. Okay, so all these three are r. Okay, all these three perpendicular distances taken from the incenter will be known as in radius. So there are two definitions of the incenter also. One is intersection point of all three interior angle bisectors will be known as incenter, and second is a point which is equidistant from each side of the triangle. Okay, which is equidistant from each side of the triangle, that is known as the incenter. Okay, and these distance should be perpendicular distance. Getting me? So you have to keep both the definitions in your mind, because these both definitions have been asked many times in the question paper, and or we can say we can use both the definitions just to simplify the questions a little bit quicker. Okay, so now let's start. Now we will discuss the properties related to the incenter. We are going to discuss the properties of the incenter. So first property we will discuss, that is about the angle at incenter. Okay, angle at incenter. So first property is angle at incenter. As we discussed in previous session, angle at circumcenter, and we discussed over there that angle at circumcenter will be twice of the opposite angle. In the same way, now we have to discuss angle at incenter. Okay, suppose this is the triangle. This is the triangle ABC. Name of the triangle is ABC. Okay, and this is incenter. This is incenter. You know very well, if I'm gonna to join the vertex with incenter, that line will be the angle bisector of angle B. Okay, suppose I'm joining vertex B with incenter I. Okay, so a line which is passing through both points, vertex as well as incenter, this is the angle bisector. And if I'm joining incenter with vertex C, this is also angle bisector. Okay, because it's the property, angle bisectors are definitely passing through the incenter. Okay, so if this angle is okay x, then it will also be x. This is y, it will also be y. Understand that? I mean to say, now this is triangle ABC and I is the incenter, and we have to calculate angle at I. So we need to calculate angle BIC. We need to calculate angle BIC. We have to calculate this. Firstly, before telling the direct formula, I just like to tell you the proof that how this particular formula is derived right here. Okay, so as you know that this is angle, complete angle B. So, and IB is the angle bisector of angle B. So I would say that the lower part of angle B will be known as B by 2. Lower part will be known as angle B by 2. In the same way, this is angle C, complete angle C, and the lower part of the angle C will be known as C by 2. Lower part of angle C will be known as C upon 2. This is B upon 2 and that is C upon 2. Now we have to calculate angle BIC. Can you see there is a triangle BIC? There is a triangle BIC. Okay, in triangle BIC, there is a triangle BIC, and in triangle BIC I can say that angle BIC will be equal to 180 minus B by 2 minus C by 2. Okay, B by 2 minus C by 2. We can say that. Now can we see that 180 minus taken common, it is B plus C by 2. Okay, and as we know very well that sum of all interior angles of the triangle will be equal to 180 degree. Sum of the all interior angles of the triangle will be equal to 180 degree. So I can say that angle A plus angle B plus angle C is equal to 180 degree. So I can say that angle B plus angle C will be equal to 180 minus A. I can say that. Okay, so now I am replacing B plus C with 180 minus A. I am replacing B plus C with 180 minus A. So I can say that 180 minus, it is 180 minus A upon 2. A upon 2. Now I am dividing each term with 2. 180 will be divided by 2, we will get 90, and A is also divided by 2, we are going to get A upon 2. So it will become 180 minus 90 minus A by, minus plus A by 2. So we will get 180 minus 90 plus A by 2. 90 plus A by 2. So this is the direct formula of the calculation of angle at incenter. Now what is the formula? Honestly speaking, angle BIC is equal to 90 plus A by 2. I mean to say, I'm calculating angle over here. So what we have to do? Angle at incenter we have to calculate. What we have to do? 90 plus half of the opposite. Okay, half of the opposite, and we have to add that half of the opposite in 90 degree. That will be angle at incenter. You can remember this in another way also, if you don't want to draw the diagram in your examination. Okay, how could you do that? As I have told you earlier in when we were discussing about the circumcenter, I told you that how can we calculate the angles at the center just without drawing the diagrams. Here I'm going to tell you again, as the triangle is ABC. Triangle is ABC. And it is clearly mentioned I is the incenter of this triangle. I is the incenter of this triangle. And we have to calculate angle BIC. We have to calculate angle BIC. I told you that always see how many vertices of the triangle are used over here. B and C. These two vertices are used over here. And vertex A is remaining. Okay, vertex A is remaining. I is the incenter. Okay, you know that. And angle at incenter will be 90 plus half of opposite, or you can say half of remaining. B and C are used and vertex A is remaining. So I will write 90 plus A by 2. Okay, if you will practice this approach, you don't need to draw the diagram while solving the questions in your examination. In the same way, I can say if I'm going to ask you calculate angle AIB, you would say that two vertices A and B are used here. Then we can say 90 plus C by 2. If I'm going to say that you have to calculate angle AIC, you have to calculate angle AIC. So angle AIC will be two vertices A and C are used here. So it will be 90 plus B by 2. Understand or not? So like that, you can calculate angle at incenter. I hope you have understood these kind of approaches or the things. Okay, so we just have discussed only one property related to the incenter of the triangle, and I have told you the proof also, that how can you derivate the angle at incenter. Actually, I thought, why is it necessary to explain the proof in front of all of you? It is also necessary for you to and for me too. If you are gonna to learn the proper explanation of each formula with their proofs, it is gonna to develop your mental ability, strengthen your thought process while you are going to face a new kind of question. Okay, so we will do now the proofs as well as the formulas and the concepts. Understand that? So it's the promise. Now we will start discussing the next property. We will understand the how can we calculate the length of Inradius. Okay, how can we calculate the length of Inradius of a incircle? Okay, suppose this is the triangle ABC, and there are 3 to 4 formulas of the calculation of Inradius. Okay, in the same way, there were 3 to 4 formulas to calculate the circumradius. Okay, in the previous session we have discussed. In the same way, we are going to discuss the formulas of the calculation of Inradius in different kind of situation. So situation number 1 says that when length of each side of triangle, when length of sides of triangle are A, B and C. A, B and C. When length of sides of triangle are A, B and C. Suppose this is triangle ABC, and in this triangle length of each side is provided. Okay, so length of one side is suppose A, length of another side is B, and length of third side is C. So length of each side is provided over here, and we have to calculate the Inradius. Understand that? So now how can we calculate the Inradius? As we know, there must be an incenter. Suppose this is the incenter. This is the incenter. Now this is the incenter, and if I'm gonna to join vertex B, vertex A, and vertex C with incenter, these will be the angle bisectors definitely. And now triangle is divided in 3 parts. Okay, these 3 parts are not the equal parts. Okay, now triangle is divided in 3 parts. Understand that? And we have discussed that Inradius will be making 90-degree angle with each side. Okay, so this is the incenter, and if I'm going to draw a circle over here, that is going to touch each side of the triangle internally, and this will be the Inradius. This will be the Inradius R. This is the Inradius R, and this is also the Inradius R. Okay, these are the Inradius. Okay, now can I say, okay, I'm gonna to discuss about the proof. Now I can say area of triangle ABC. AR means area. Okay, area of triangle ABC will be equal to area of triangle ABC will be equal to area of triangle AIB, area of triangle AIB plus area of triangle BIC, area of triangle BIC plus area of triangle AIC, area of triangle AIC. I can say that the area of triangle ABC will be equal to sum of these, sum of area of these 3 triangles. Okay, Now, suppose I'm denoting the area of triangle ABC with del. Okay. Now, can I say area of triangle AIB will be equal to, area of triangle AIB will be equal to 1 by 2 C into R, C into R, using the formula 1 by 2 base into height. In the same way, I can say area of triangle BIC will be equal to, BIC will be equal to 1 by 2 A into R. In the same way, area of triangle AIC will be equal to 1 by 2 B into R, 1 by 2 B into R, and R is taken common. R is taken common. 1 by 2 R within bracket A plus B plus C. You know, A plus B plus C by 2 will be equal to A plus B plus C upon 2 will be equal to S. You know that S is equal to A plus B plus C by 2. Understand that? So I can say A plus B plus C upon 2. This is S. Okay, this is S. So I can say del is equal to R into S. R multiply S. Now I can say R will be equal to del upon S. R will be equal to del upon S. So this is the first formula. This is the first formula of uh, calculation of inradius of a triangle. Okay, for the calculation of inradius of a triangle. But especially remember that this formula will be used when length of each side of triangle is provided, or the area of triangle is directly provided in the question, or you can calculate area of the triangle applying any kind of formula, and semicircle, so sorry, semi perimeter of the triangle is also provided in the question. Okay, so you have to use these things remembering the condition provided in the question. Okay, getting me? Now we will do two questions, each on each kind of property. One question on the previous property and one question on this property. We will simplify two questions. After that, we will move to the next property. Getting me? Okay. So the first property was just about the angle calculation at the center. So I'm giving you a question and you have to simplify this. In the question it is said that in triangle PQR, in triangle PQR, in triangle PQR, I is in center. I is in center of the triangle. I is in center of triangle. In triangle PQR, I is in center of the triangle. Okay. Angle Q equal to 60 degree. Angle Q equal to 60 degree. Angle R equal to 70 degree. Angle R equal to 70 degree. Angle R equal to 70 degree. Find angle QIR. Angle QIR. We have to find out this. Okay. And I'm gonna to provide you the solution of this question. And solution is gonna be very easy. Okay, I'm gonna to provide you the solution of this question. And solution says that the name of the triangle is PQR. What is the name of the triangle is? Name of the triangle is PQR. Okay, and there are the three vertices of the triangle. One is P, another is Q, and third is R. Understand that? And I is the incenter. It is clearly mentioned over here. And values of angle Q and angle R is also provided here in the question. And I need to find angle QIR. Okay, so what can we do over here? As we discussed, firstly we will see that which vertices of the triangle are used over here. Okay, so we have to calculate angle QIR. Angle QIR. So two vertices of the triangle Q and R. Because triangle is PQR, it has three vertices P, Q, and R, and two vertices Q and R have been used over here. So angle QIR will be equal to 90 plus P upon 2, isn't it? Yeah, definitely it will be equal to. And now if I know the value of P, I'm going to place it. I'm going to get the answer. In the question, it is clearly mentioned that angle Q is 60, angle R equal to 70. So Q plus R equal to 60 plus 70 equal to 130 degree. And we already know that sum of all angles of the triangle is gonna to be 180 degree. So I will place the value. So angle P will be equal to 50 degree. It is obvious. Okay, so I'm gonna replace over here 90 plus 50 by 2. It will become 90 plus 25, and the answer is 90 plus 150. Okay, so this is the answer. Getting me? So you just have to use the approach in the right form. Okay, just to save the time when you are attending the question paper. That's only the way. Okay, now we are going to move to the next question, and that next question will be based on the second property we have discussed, the formula R equal to del upon S. Okay, so how can we calculate the inradius when length of each side is provided, or directly the area of the triangle is provided in the question? Okay, when we have discussed, we have completed all the properties related to the triangle, we will do lot of questions which we have been asked in different kind of examination in previous year, like SSC, like CDS, and in other exams also. Okay, and after that we will start discussing quadrilaterals. Okay, and we will do the questions of all the questions of the quadrilateral, and as well as we will discuss the circles, the properties of the circles, and at the last of the session we will do miscellaneous questions, some questions from the triangle, some questions from the circle, some questions from the quadrilaterals. We are going to do all these kind of things. Okay, so stay tuned with me. Okay, so question number 2 says that, question number 2 says this: in triangle ABC, in triangle ABC, in triangle ABC, AB equal to 13 centimeter, AB equal to 13 centimeter, BC equal to 14 centimeter, and AC equal to 15 centimeter. AC equal to 15 centimeter. Find in radius of the triangle. Find in radius. Find in radius. Okay. Find in radius of the incircle. Okay. Now we know very well the formula here in this question. Length of each side of the triangle is provided, and we have to calculate in radius, okay, of the incircle. And we already know that formula of in radius is equal to, formula of in radius is equal to R equal to del upon S. R equal to del upon S. And del is equal to, okay, del is equal to under root S, S minus A, S minus B, S minus C. And S is S. Okay. Now we can calculate the value of S. So S will be equal to sum of all three sides by 2. 13 plus 14 plus 15 upon 2. And we will add all these. It will become 42 by 2. S is equal to 21. Now we are going to place the value of S over here in this formula, and we are going to get in radius of that incircle. Okay. So this is the square root symbol. S is 21. Firstly, we will have to write S minus A. 21 minus 13, it will become 8. S minus B, 21 minus 14, it will become 7. S minus 15, it will become 6. And now upon 21. Okay, 21. Now we will simplify this. Okay, so this is 21, and you know when you are calculating a square root, you just have to get the factors in pair form. Okay, this is 21. If I have another 21, I can directly calculate square root of that. So this is 7, and the factors of 6 are 3 into 2. So this is also 21. So square root of 21 multiply 21 will be 21. And 8 into 2, 8 into 2 will be 16, and square root of 16 is equal to 4, and upon 21. 21, 21 cancel, so answer is 4. So this is the in radius of this triangle where length of sides is provided 13, 14, and 15. Getting me? So these two properties we have discussed, and their concept and detailed solution and the proof we have also discussed over here. Okay. Now I have one more formula for the calculation of length of in radius. Okay, but that second formula will be used when length of each altitude is provided. Okay, you know very well there is a triangle, and this triangle has 3 different altitudes. So if length of each altitude is provided, in that condition, how can we calculate in radius? It is a question for us. Okay, suppose now I'm writing the condition first. If length of each altitude is provided, length of each altitude is provided. If length of each altitude is provided, then in radius, okay, I'm doing a triangle first. Okay, we will discuss that. Suppose this is a triangle, understand that, and its all altitudes have been provided here. Length of first altitude is h1, length of the another altitude is h2, and length of the third altitude is drawing again. Okay, it is not clear. I'm saying that this is a triangle ABC, and I am drawing all three altitudes of this triangle. I'm drawing all three altitudes of this triangle. So first altitude is this, and length of this is h1. Length of this altitude is h2, and length of this altitude is h3. Getting me? So in the questions many times you will be provided the length of each altitude, and the examiner is directly saying that calculate in the radius of the circle. So firstly we will try to understand the proof. How can we reach over there? Okay, and then directly at the last we are going to get the direct formula, and we will use that formula while we have to simplify the questions. Okay, so suppose length of this side is a. Length of side will not be provided here in the question, only length of altitudes will be provided, and length of this side is b, and length of this side is c. Okay, can I say that del will be equal to, delta will be equal to 1 by 2 a into h1, a into h1? Yes. Now can I say that a will be equal to 2 del upon h1? So this is equation 1. In the same way I can say b will be equal to 2 del upon h2. In the same way I can say that c will be equal to 2 del upon h3. Okay, if I am going to add all these three equations, I'm gonna to add all these three equations, what I'm gonna to get? I'm gonna to get that a plus b plus c, a plus b plus c will be equal to 2. I'm writing at the next page. Okay, if we are gonna to add all these three equations, what we are gonna to get? We are gonna to get that a plus b plus c will be equal to 2 del upon h1 plus 2 del upon h2 plus 2 del upon h3. It will. Okay, now what I'm going to do, I'm going to bring that 2 del in left hand side. Okay, after taking common I can say that a plus b plus c, take 2 del first common. Okay, del is denoting to the area, you know that. Okay, 1 upon h1 plus 1 upon h2 plus 1 upon h3. Now 2 del is multiplying in right hand side, and if I'm going to shift it in left hand side, it is going to divide. Okay, so it will become a plus b plus c upon 2 del upon 2 del equal to 1 upon h1 plus 1 upon h2 plus 1 upon h3. It will be like this. Okay, now suppose, okay, you already know that a plus b plus c upon 2 will be equal to s, a plus b plus c upon 2 will be equal to s, a plus b plus c upon 2 will be equal to s. Don't you know this? You know this very well. So a plus b plus c upon 2, it will become s. So it is s upon del, and it is 1 upon h1 plus 1 upon h2 plus 1 upon h3. Okay, and you very well know that r is equal to del upon s. So 1 upon r will be equal to s upon del, So I can write here 1 upon r. Yes or no? So direct formula will become 1 upon r equal to 1 upon h1 plus 1 upon h2 plus 1 upon h3. So this is the direct formula for the calculation of inradius of the triangle. Getting me or not? So you just have to remember the things. Okay, for the calculation of the triangle you just have to remember this formula. You just have to have this formula in your mind. But if you want to mentally develop your brain, okay, if you want to strengthen your mental ability in perspective of mathematics, okay, in geometry, okay, then you should go through the entire proof. Understand that? So in this video we will discuss these things only, and second part I'm going to introduce related to the incenter of the triangle. In that second part we will discuss the remaining formulas as well as some questions related to those formulas. We will do one more question over here based on this property, and that question has been asked in previous CDS examination. Getting me? So there is a question for all of us, and we will do that question. Okay, in the triangle it is said that length of altitudes length of altitudes altitudes length of altitudes of a triangle are 15 centimeter, 12 centimeter, and 20 centimeter, and 20 centimeter. Find in radius. Find in radius. Okay, this is the question. Okay, find in radius. Understand that? Once we have completed all the properties, I will bring the questions in typed form. Okay, there will be the PPT of the questions and of all the questions. Okay, so many questions will be there, but when I'm teaching you the concept and the properties, I will have to write here, and just for the better understanding, I'm just providing you one question based on each property. Okay, once we have completed all the properties, we will do so many questions, then the questions will be already typed here. Okay, so don't worry about the time. Now we will simplify this question, and we know the length of each altitude is provided here, 15, 12, and 20, and we have to calculate in radius. So length of sides is not provided here, and now we have to calculate the in radius. So we are going to use very simple formula, and the formula says that 1 upon r is equal to 1 upon h1 plus 1 upon h2 plus 1 upon h3. This is the formula. And we know that h1 is equal to 15. So 1 upon 15 plus 1 upon 12 plus 1 upon 20. This is the formula. 1 upon r equal to, now we will have the LCM over here. It is 60. So 4, 5, and 3. So it is 12 upon 60. 12 upon 60. So it will become 1 upon 5. So 1 upon r equal to 1 upon 5. Okay. 1 upon r equal to 1 upon 5. So we can say r equal to 5 centimeter. Okay, so students, it's enough in this video, and now we will study after some time the second part of this video. Okay, and one more thing I wanted to tell you, from next week onwards I'm gonna to upload 4 to 5 more videos. Okay, means in a week you are gonna to get 6 to 7 videos. Understand that? In a week you are gonna to get 6 to 7 videos. 4 videos or 5 videos will be based on 10th class mathematics. So as I have promised you that I'm going to upload the entire syllabus of 10th class maths on this YouTube channel. Okay, but everything will be in English only, as I have promised to myself that I will upload the solution of the entire 10th class mathematics only in English, because students have been already studying from other YouTube channels in Hindi or in bilingual form. So I have promised to myself that I will provide the solution only English to all the students who love to study the 10th class maths in thoroughly in English. Okay, so it will be helpful for you, and I would suggest you that you start focusing on English too, because it is very good for you to be fluent in English, in speaking, in understanding. Okay, it is gonna to improve your communication skills, and once you have acquired this kind of quality, okay, you are gonna to feel very confident. It's my promise. Understand that? So just be consistent. If you are gonna to be consistent, things are gonna to definitely improve. Okay, and there is nothing which can stop you. And when on the daily basis you are improving to yourself, you are gonna to get confident. Okay, and there is nothing which can create fear in you. Okay, and you are not gonna to feel fear about your future, that what the future is gonna be, because you are gonna to believe in learning. The person who always believe in learning, he never love to give up. Okay, he never loves to give up. Understand that? So it's my promise to all of you. So stay tuned, and we will meet in the next video. Thank you so much. Bye bye.